Cool. So good morning all. Hope everyone is doing great. So today's topic is kind of designing some video conferencing system like Zoom, right? So that's the agenda for today's topic. So we'll talk on how to design the video conferencing application like Zoom, right? Feel free to stop me if you have any questions. If I'm not audible, feel free to stop me, and I'm happy to repeat any topic again if there is any confusion. Okay. Yeah, so as mentioned, the agenda is designing a video conferencing application similar to Zoom, right? So we'll first talk about the functional and non-functional requirements, and also we talk about certain prerequisite tools and protocols that is required in order to design. And we'll talk about our design, what is our high-level design, how we are trying to design this Zoom application. We'll go in detailed design and other aspects, right? I do have a few slides, like around 7-8 slides, but most of the session will be like little live, like we will be kind of talking on the logical view or the logical architectural view on how we are trying to design our application. Okay, Zara, are you on the call? Okay, fine. So yeah, the video audio conferencing system design, right? So today we'll talk about how to design the video and audio conferencing system, right? There are multiple offerings in the market like Zoom, Microsoft Teams, Cisco WebEx, and many more, right? So how we can design these systems? So that is our main agenda for today's session. So first talk about the functional requirements, right? So what is the requirement, right? Like what is the exact business ask here, right? So the requirement is like we need to support one-to-one call, like peer-to-peer call, right? That's one of the requirement, right? And also we can support a group call, or like just like this, like multiple people can join a video conference and they can talk or they can share their videos and all, right? And also we need to have the capability to share a screen and all, okay? And also the record session, right? So it's feasible, we want to record the session just like how we are doing it, how we are recording our session, right? And also the message communication, apart from the video and audio on the chat, something similar to chat. We can share the chat. I mean, we can share the messages between the involved participants, right? I think that's the functional requirements which predominantly we kind of see, right? So as a technical person or a architect for this design, right, or for this problem statement, what are the non-functional aspects you can think about? So based on this requirement, right? Okay, yeah, I think we know what is the functional requirements, right? So based on the functional requirements, like after talking to our business owner or the product owner, so we understood certain non-functional requirements as a technical engineer, right? One of the non-functional requirements is like it should be super fast, which is the performance, right? Since it's a video and audio call, things should be very real time, right? So that's what one of the non-functional requirement which we have understood. And it should be highly available, right? So we should not have, meaning the application should be accessible 24/7, right? So one of the other non-functional aspect is high availability, right? And scalability. If you know, if you see Zoom, we have a lot of users, like billions of users as well, right? So we need to build a system which is more scalable in nature, right? Considering the current Zoom users and the usage, right? So I believe like we need to have a scalable application, right? Data loss, okay, what does it mean is when I spoke with my business owner, like he mentioned that, hey, if there is a network lag, just like what we have seen right now, okay, so you guys are not able to hear me or not able to see me for a fraction of seconds or couple of seconds, right? Do I require to is that okay if that data loss during that point of time there is a network latency, right? And the answer is okay, yes. If for some reason the user is not able to connect or there was some network latency or something like that, the data packets has been lost, it's okay, we can ignore that, right? That's what I learned. Okay, so the data loss is okay. Of course, security, right? So we need to be building some reliable connection, right? Sometimes the confidential information might be discussed. So when the data has been transferred over the network, we need to ensure the security has been taken care, right? And all aspects of security need to be taken care. Okay, and agility, what does it mean is, hey, today we are offering this service in India, tomorrow we might go to other countries, so there might be more requirements in future, right? So you should build a system which is capable enough to support those kind of things, right? Or we can add new functionality. Okay, so as of now we have these things, maybe we can add some kind of a background, what do you call it, setting the background for the user. When the audio is turned on, we want to set up the background, just like what we see right now in Zoom and others. They do support various background options, right? Maybe those are like in future, those could be a requirement, we need to support that, right? So these are the non-functional requirements I kind of identified based on talking to my business owners. Okay, so considering all these functional and non-functional requirements, I need to come up with my architectural proposal, like what is my architectural style, which architecture I want to use, right? So I might have talked about various architectural styles in my previous session. If you're not able to attend that, maybe there could be some recording available, so that will be shared to you guys, right? But considering these functional requirements and non-functional requirements, right, I think microservice architectural style will be better suited. The reason is, if you see here, scalability has good, means microservices has good scalability options, right? So these are the ratings or the points for the microservice architectural style, right? So with microservice architecture, scalability goes well, elasticity goes well. What does that elasticity mean? So today on Zoom, there could be, on a given day on Zoom, there could be 100 users only, right? 100 users are using the Zoom application. But let's say there is some event, let's say some celebrity, like let's say prime minister of a country or someone is talking on Zoom. Maybe a lot of people will be accessing the Zoom application, right? So at that point of time, we might have millions and billions of users joining that platform, right? So on a given day, we might have 100 users, or at a given day, we might have billions of users, right? Which is like a scale, elasticity, right? Just like an elastic band, we can expand as well as we can contract with respect to the user traffic, right? So those are certain what do you call the requirements, non-functional aspects which we identified, right? So based on these functional and non-functional aspects, I determined to go with the microservice kind of an architectural style. Okay, I see a question. Okay, fine, sorry. Okay, yeah, so now we have identified the architectural style, which is microservice architectural style, right? That is what we have identified. Okay, and we want to make certain principles, certain architectural decisions in order to make a system design, right? So to identify these principles and this architectural style, we need to take a lot of exercise. We need to think about various aspects. I'm not going in detail there considering the time, but let's assume the architectural style has been identified based on these parameters, which is microservice architectural style. And we have identified various decisions and principles, like we will be using APIs for all communication. Okay, whenever applicable, we want to make it as asynchronous communication. right? So we don't want to confine only to the relational database. If required, we can use the NoSQL DBS as well, right? Build system which is extendable. In future, we need to add maybe some kind of a analytical aspects or some kind of a learning aspects as well, right? So in order to support new functionalities, we need to track each and every call in some means, the metadata about the audio call, some metadata about the video call, so that we can provide better experience to our customers. Okay, so this is what we kind of identified so far based on the problem statement. So I'll stop here to see if there are any questions. So far good?
Yeah.
Okay, great. Okay, fine. So before we go in detail, right, so let's talk about certain prerequisites, right? Basically, we'll be talking about certain web protocols, right? So because the understanding these protocols will help us to understand our design much better, which we'll be talking shortly. Okay, so I know most of you guys have attended some of the previous system design topics on WhatsApp, right? Like how to build that WhatsApp application and all. I'm sure people might have spoken about the protocols like WebSocket and all. Okay, but yeah, but let's talk something basics. Let's talk about the communications in basics, right? Okay, there are a few people waiting. I guess let me admit them. Okay, fine. Okay. Yeah, so generally how the communications will happen, right? You have a client and a server. So this is a client. You're able to see my screen, right? And this is a server. Okay, so when we via various protocols, right, like network protocols like TCP, UDP, and all that, right, and HTTP, application protocols like HTTP, we kind of communicate between the client and the server. We send a message to the from client, we send a message to the server, and server gives us the response back, and we use that response, right? This is a typical HTTP request response mechanism which we generally use. Okay, so this looks good. This is a one-way communication. So client is asking some information and we are getting the response back, right? But the applications like video, audio, or a messenger, or a conferencing applications, we need a little peer-to-peer communication, meaning I have a person A, right? And I want to send a message to person B, right? So this is person B, right? I want to send a message to this guy, right? How I can send that? Okay, so there also we have various protocols, right? Like WebSockets and all, which will support bidirectional communication, right? So suppose it supports from client to server as well, it will support the bidirectional communication. Okay, right? Or it could be a server, or it could be any other client application as well, right? Any server, right? So in order to have a duplex or bidirectional communication, right? So what we had is we have a protocols like what do you call sorry, yeah. So protocols like WebSockets, right? So that's work well, right? I am assuming people are aware of the WebSockets, but if you need more details, maybe if time permits, I'll talk more about WebSockets too, right? But in short, the WebSocket is a bidirectional protocol, right, between the client and the server, where the information is being transferred from client to server. Okay, so in a message communication applications like WhatsApp or your Facebook Messenger or anything, sometimes we kind of go with this WebSocket protocol as well, right? So what happens here is this connection is established between the client and the server. That will be live, right? So it will be live so that the message from the client will be to the server can be passed, and to and fro communication can be happening via this WebSocket. Okay, so that's a protocol. So the WebSocket is a protocol for low latency bidirectional communication initiated via the HTTP HTTP only, right? So this is useful for sending and receiving the text, binary arrays, blobs, right? So this provides full duplex communication over the TCP. Okay, so this is the WebSocket. Okay, okay. Any questions so far? Hope you're good on this protocol. Okay. So along with WebSocket, there are various other protocols which is more prominent in today's market, specifically for real-time communication or specifically to implement the applications like video conferencing. One of the most prominent protocol is Webrtc, which is another protocol identified or standardized by Google, right? So this is the web real-time communication protocol, right? So it's a free open source protocol, which we can use within our browsers or within our applications to provide a real-time communication, right? So this protocol can be used for building the video conferencing or message conferencing applications, as well as it can be used for gaming as well, right? Like in the game also, you have the real-time communication and various other use cases. Okay, so this is a kind of a protocol which we will be using to build or to design this video conferencing application as well. Okay, so this protocol we can leverage this protocol via the APIs, right? So we have basically within the WebRTC world, we have basically 3 APIs, which is get, user, media, peer communication, and data channel. I'll talk in detail, but these are the APIs, the predominant primary APIs, right? Which will help us to provide or establish a real-time communication. Okay, so here, if you see via this protocol, what we are doing is we are providing a peer-to-peer communication between the users, right? Example for our requirement of one-to-one call. Example, person A is talking to person B. So here we have established a connection between person A and person B via the WebRTC protocol. Okay, we'll go in detail, right? I'll explain this protocol in detail and what are the components we have in this protocol, right? So the WebRTC is a protocol, right? And it internally leverages a framework called ICE framework, Internet Connectivity Establishment, right? That's the framework, right? The ICE framework. Sorry, interactive, not internet. Sorry, interactive connectivity establishment, right? So that's the framework which internally it leverages to implement this protocol. Okay, so this supports both TCP and UDP as well, UDP and TCP network protocols as well. Yes, we can have, so Ranjit, your question is, can we have a video call through WebSocket? Yes, technically, yes, right? We can have video call via the WebSockets, but again, so here, if you go to the WebSockets, right, like how the WebSocket communication will happen is something like this, right? So let's say you have a client A, okay, is talking to client B, right? Client B, right? So you will be having a server in between, okay? And then I'll explain the details as well, right? But something like this, it will be to and fro communication. I need to change the. So this is how it will be in the WebSockets, okay? So yes, we can establish the video call via the WebSocket protocol as well. But since if you see here, there is a server intermediate. So considering the our non-functional requirements of super fast, the performance and all, right? So we don't use WebSocket for that, right? But technically, yes, it is possible. It is how we can implement it as well. But using this WebSocket protocol, there will be some delay in data transfer, right, which may not meet your requirement, which is super fast. Did I answer your question, Ranjit? If not, maybe I can go in detail also how the WebSockets work. Okay, maybe I'll take one of the example here. Okay, so let's say the user one want to send a message to user two. Clear, right? So the request is user one want to send a message. Let's say this is a WhatsApp kind of an application or some kind of a messaging application, right? So user one wants to talk to user two. So what happens is this user one will be connected to some WebSocket handler to establish a bidirectional communication. We are communicating with a WebSocket handler. Okay. Similarly, this user 2 is also connected to one of the WebSocket, which when I say WebSocket, this is nothing but a server within the WhatsApp, right? Meaning the WhatsApp infrastructure, you have multiple servers, right? So the user one, let's say who is in India, he is connected to nearby WhatsApp server in India. Whereas let's say user one who is in US, right? He is connected to one of the WhatsApp available server in US, right? This is how it has been happening. Okay. Let's say the user A, user one who is in US sending a message, right? Right. What happens is sending a message to user two. What happens is that message will go to this the WhatsApp WebSocket handler one. Okay. What the information will be there? Hey, user one want to send a message hi to user two. Please send that. Okay. That's the information has been sent to this guy. Okay. Now the WhatsApp, the WebSocket handler, what it does is it will store, first thing is it will store that message in its database. Hey, this user one has sent a message called hi, please store it in your database. Okay. As soon as I get the message, okay, I'll store that message in the database. Good. So far good, right? After that, what happens is now, sorry, is there any question? Okay, fine, right? Okay, so we got a message, right, from user one, right? And we have stored, hey, if you're not talking, please be on mute. There was some disturbance.
Sharad, you can mute the person.
Yeah, I have muted Pooja. Okay, fine. Okay, fine, right? Okay, so now, yeah, so user one sent a message, right? That request has been reached to the WhatsApp, WebSocket handler one, right? WebSocket handler stored that message by calling the messaging service, right? And then now I'm going to the WebSocket management. What this guy will do is, this guy will maintain a catalog or a kind of a registry saying that user one connected to which WebSocket handler. What you will be having is in this database, you will be having something like this, right? Let me add a text, right? In this database, you will be having something like this one. User one connected to socket handler one. Okay. User two connected to socket handler two. So this is how it has been maintained in this database, right? So now what I'm doing, I have the message is been stored. Now I'm going to this guy and asking, hey, I want to know where this user two is. Okay, we look at this registry and we identify that this user is in the socket handler. He's connected with socket handler 2. Okay, now what we'll do, this socket handler 1 knows that the user 2 is there in the, or he is connected to socket handler 1. What it does is this guy will send a message to socket handler 2 saying that, hey, please send hi to your user or to the user 2 which is connected to your port. Okay, so what happens now? Via this WebSocket handler 1, we are sending a message to WebSocket handler 2 to relay that message to the user 2. Okay, so this is how typically the WebSocket functionality will work. Understood? Step number 1, user 1 sends a message, right, via the WebSocket connection. Okay. Step number 2, the message has been stored in the database with the status saying that I have not delivered. I received your message, but I have not delivered, right? Now, via the WebSocket management, we are trying to identify whether the user 2 has been connected to our application or connected, or whether he is online. If he is online, what is the WebSocket through which he is connected? We are identifying the WebSocket of the user 2, which is WebSocket handler 2. So now we know that the user 2 has been connected to the WebSocket handler. So now what we are sending a message from handler 1 to handler 2, and handler 2 will ensure that message has been relayed back to the user, which is the client. Okay, so that's how typically functionality will work. Hope it kind of explained your query, Ranjit. Okay, fine. I think there was one more question, Avinash. Okay, thanks, Ranjit. Yeah, Avinash. In case of Webrtc, if one, okay, yeah, maybe Avinash, maybe I'll explain Webrtc in detail, right? And then I'll talk about your question as well. Okay, hold on for your question for some more time. Okay, thank you. Cool. Okay, so this is how the WebSockets works, right? So now so since there is some to and fro between server and client, it's not a peer-to-peer communication. So in order to make it super fast, we are leveraging a different protocol called Webrtc. Okay, fine. So using the Webrtc, we are kind of establishing a peer-to-peer communication between the two clients. So this way, the communication is super fast. Okay, cool. Yeah, we'll go in detail. We'll talk about Webrtc in detail, and we'll see the internal components of the Webrtc as well as the architecture of Webrtc, right? So along with Webrtc, so there is some new protocol which is being discussed that is called Web Transport, right? So that's again in the early stages, but I think there is some discussion around Web Transport. Maybe that might replace WebSockets and Webrtc in future, right? But as of now, it is very early stages. Maybe after 1 year, maybe we will be discussing about the Web Transport Protocol too, right? Just an information, right? Nothing to do anything with our design. Okay, so let's talk about what is Webrtc, right? So the Webrtc is a real-time peer-to-peer communication protocol. Okay, right? So peer-to-peer communication has been established in this Webrtc by leveraging a framework called ICE, which is Interactive Communication Establishment, Interactive Connectivity Establishment. Okay, 1 second. Okay, fine. So yeah, so the peer-to-peer communication has been established via the ICE framework, okay, to overcome the complexities of a real-time, real-world networking, right? Okay, I'll talk in detail, right? So, but let's take an example, right? Let's take a practical example to understand certain basic aspects. Okay. Okay, so let's say there is a user 1, okay, and there is a user 2. Okay, so both these guys want to, again, I'm talking from the layman terms, nothing to do with any of the protocols or anything like that, right? But I'm trying to explain the concepts of Webrtc with an example, right? So there are two users who want to communicate each other. They want to have a video call or some kind of a peer communication need to be established. Okay, how I can talk each other, like peer-to-peer communication can happen if I know the details about this user, right? If I know who is the user, what language he understands, right, and how far he is, based on that, only this user 1 can talk to user 2, correct? Right? If the user 2 cannot understand English, right? Maybe I need to use some translator to convert English to his native language or the language which he understands and all. So basically, I want to know where this user 1 is, the user 2 is, so that I can talk. So in order to establish a communication between user 1 and user 2, you need to know the details about the user. Okay, right? So that's the basic principle. But we are connected over the internet, right? So this, let's say this user 1 is somewhere in India. Okay, and he is connected to internet by using some kind of an ISP provider. Let's say Airtel. He is using Airtel ISP or the Airtel broadband to connect to the internet. Okay, so this is how the user has been connected to the internet, or via the ISP he was able to connect to the internet. Let's say the user 2 who is also in India, right? He is also connected to internet, right, via some kind of, let's say, ACT broadband or Geo broadband, whatever it is, right? Geo broadband. Okay. Okay, fine. So this is how both of them are connected to the internet, right? Both the users 1 and user 2 are in the internet, right? But how they can talk, how we can establish a peer communication, right? Because I don't know this person's IP address, right? As a user 1, I don't know the user 2's IP address, right? It's very difficult for me to get that. So typically what happens is, right, so your Airtel, when you're connected to the Airtel, it will go to the Airtel's router. There will be multiple routers, but simplicity, let's say we are talking about some public router or some kind of a endpoint of the Airtel router. Okay. Similarly, this Geo will also have some router. This is a public router. You might have n number of routers. Let's say you are in Bangalore, in MG Road, you might have a router. And if you, let's say you are staying in Bangalore, maybe in Marthali, there will be one more router like that, right? Let's say this person is in Hyderabad, like in Hyderabad, let's say in some area, high-tech city, there might be some router and all that. Okay, so multiple intermediate routers will be there, but this is the public router for India, or public Airtel router, or public Geo router. Okay, so this is public space, right? Meaning anyone can access. This is a public routers. Okay, so this is on a public platform, something like this, right? Okay, let me take 1 second. Let's say this is a kind of a channel where all this public routers are being connected, right? Something like this. Okay, so now, so what happens is if someone sends a message, right? So we will be talking to this Zia router, which is available publicly, right? So we only can talk using the public router. I cannot, I mean, these guys can talk each other because they are connected. They know the public IP addresses and all. Okay, so generally what happens is there is something called NAT. Okay, so this user 1 will have some IP address, let's say 10.0.0.1. This is a private IP address for that user. Okay, and also this user 2 might have some IP address, let's say 196.0.0.1, right? This is the private IP address of this guy, right? So these are private to Airtel. This is private to Airtel, and this is private to Zio. Okay, but there will be public IP address at the Airtel end. Let's say the public IP address is something like that, 44.45.46.78. This is the what you call the public IP address, right? And again, there is some kind of a signature or some kind of a range as well. So private IP address need to start with 10, something like that. There are certain rules, but it's out of our scope. Okay. So what happens is this is the public IP address. So under this, there are n number of systems or n number of computers which are connected within the Airtel router. For each and every computer, they will be creating a port number. Hey, for computer 1, use this public IP address with a port 1. Okay. For computer number 2, use this public IP address with port number 2, right? Something like this, right? This is how we will be having it, right? This is called NAT. NAT translation is nothing but network address translation, right? So the private IP address is been translated to the public IP address, right? Why it has been done? Because of a security reason, as well as we may not have huge number of public IP addresses. So we want to reuse the public IP addresses, existing public IP addresses. That's the reason we use this NAT functionality, right? Hope you got it, right? So what we're trying to do is we are trying to convert the private IP address to the public IP address. Okay. And similarly in the Zio, we will be having something like this. Let's say 56.76. Okay. .3 port number is 6, right? The same thing, port number is 7, etc. So let's say there are two users, two computers, right? One computer is connected to this public IP address with port number 6. Another computer has been connected to this public IP address with a port number 7. Basically, these private IP addresses are translated, right? You can see there is two IP addresses we have, 1 and 2. Let's say this one private address is translated to or mapped to this public IP address, okay, with port 6, right? And this guy has been mapped to this public IP address with port number 7. So now these are public IP addresses. So now using these public IP addresses, we can do the communication. So let's say, right? Let's say I know the public IP address. This is the public IP address, right? So, and I know the public IP address of this particular guy. Okay, sorry. Right? So this is the public IP address. So what happens? So now this using these public IP addresses, we are able to communicate each other, right? We are able to establish the connectivity, which means that the user 1 in the Airtel service provider is able to talk to the user 2 in the Zio by accessing his public IP addresses, right? So this is one way of establishing the peer-to-peer communication. I'm trying to kind of simplify it, but a lot of things are there in the internally, but this is how it happens. So what the concept you are talking here is NAT translation, converting the IP private IP address to the public IP addresses, right, is something called NAT translation. So we want to leverage the NAT to understand our public addresses so that we can establish a peer-to-peer communication. Okay, I'll stop here to see if there are any questions. So Pooja, your question is, if we translate the private IP to public IP address, won't there be a security issue? No, right? I mean, answer is, again, there are multiple answers to that. So, but what happens is, within the, this is your public IP address, right? This is your public IP address. Someone is accessing your public IP address. So what happens is, you have a lot of firewalls established here. So if the user from the Zio is sending some message, some bad message or some security aspect, so it will bypass or it will go to the firewall. So the firewall will do the filtration. So before translating before sending that the message to the private user or the user 1, we will the message will go over the firewall where the filtrations will be happening, right? Okay, so why are we kind of doing the translation? One of the reasons which I mentioned was security, right? Via this, right, we can have some configured set of rules in the firewall at the Airtel ISB level, which can block or which can do certain filtration as well, right? So this is how they address the security, at least from the Airtel ISP provider perspective. Not sure if I answered your question, Pooja. Right. So there are cases, they do certain example banks, like security organizations like banks, they think that even though the firewalls are established at the Airtel, but they do implement their own firewalls. We'll talk about those cases as well in our design session or in our design discussion. Okay, thanks, Pooja. Okay, cool. Okay, so I think now we understood, right? So via the NAT, right? We can able to identify the public IP address and do the what you call peer-to-peer communication, right? So this is how the picture talks about, right? So this is the user number one, want to talk to user number two, right? But both are behind the NAT as well as the firewalls, right? So since I don't know the IP address of this user two, which is on the right hand side, right? So I need to rely on some framework which will help me to establish a peer-to-peer communication. So basically what we're talking is we're talking about peer-to-peer communication. Okay. So how it can done? There is something called signaling service, a signaling server. What it does is user one want to talk to user two, correct? What he does is he send a message to the signaling server. Okay, hey, I am user one. I want to talk to user two, right? And he will be sending some kind of a metadata. We call it as SDP. I think session description protocol, right? Maybe I'm not sure if I added that. Okay, fine. So basically here, the user one is sending the information about him to the signaling server, right? What message he is sending? Basically, I think I forgot to add that, but I'll add it right away. He's sending a message, right, to the signaling server called as DP, Session Description Protocol. What is this message? This is nothing but in a layman terms, we call it as offer. He's sending an offer message. What is the offer he is sending? Hey, I'm offering person you to take my call, right? And this is the information about me. What is this SDP will have? Session description protocol. It will have who is the user, what is the IP address of the user, right? What is his bandwidth, right? Or what is whether he's running on a low bandwidth or high bandwidth, those details will be mentioned within this SDP, right? It's basically sending the metadata about the user, right? IP address of the user, bandwidth of the user, and codec, right? Hey, I am using low bandwidth, so I'm accepting only the low pixeled video, right? I'll accept your incoming video, but that should be very low pixeled, right? If it is a high definition, maybe I may not be able to access those details, codec specific, I mean, coding and decode and code kind of a mechanism, right? Those details will be mentioned over here, right? So what happens? So the user one wanted to establish a peer-to-peer communication. So he is talking to some server, right? Okay, via, let's say, WebSocket or any other protocol, okay, to this server, saying that, hey, I want to talk to user two, right? And this is my offer request, okay? This is my offer request. This offer request has SDP. It has details about the IP address, bandwidth, and other metadata. Okay, got it? So what the signal server will do is, server will send that details via the WebSocket. It will send that details to the user two. Okay, hey guys, we have an offer. Do you want to accept this offer? Right? What it will do, it will send the same request, right? Again, the WebSocket kind of a communication. Hey, we have an offer from user one. He's saying that he want to talk to you, right? So this is the details about the user. So the offer request has been sent to the user two. Now what user two will do? Hey, looks good for me. All looks good, right? I want to accept this guy, right? Everything looks fine. I want to talk to him, right? Let's say he has accepted our green button and red button, right? Right? He accepted on the green button, which means that he accepted the call. What we are doing? Answer. We are sending, meaning the user two is sending in an answer request. Again, it is also in the SDP protocol, session description protocol. So now the user two, what it is saying that, hey, I'm good to accept the user one, right? And these are the details about myself. This is my IP address. This is my bandwidth. I'm also on the low bandwidth, and I accept so-and-so video conversion. Video should be in so-and-so range, low pixel or high definition. All those details will be sent to this guy. Okay, so this is the answer. Okay, so what the signal server will do is, it will store the metadata about the user 1 and user 2 in his database. Okay, so now the signal server know how these guys can communicate, what bandwidth they are in, right? If user 1 is on a low bandwidth, it will ensure, or we need to ensure we are sending the low configuration video to the user 1, right? And if the user 1 is in high configuration, maybe we need to convert the video into the high quality, right? All those aspects will be stored in this signal server. So basically the signal server, which will have the metadata about the user 1 and the user 2 in our use case. I'll stop here to see if there are any questions. Does it make sense, first of all? I'm happy to repeat if there is a question or a confusion. Right? Or just in short, right? What is a signal server? Signal server is a server, right, where it stores metadata about the user 1 and user 2 as well, right? So that we can establish a peer-to-peer communication. So in layman terms, signaling server will have what language the user 1 talks and what language user 2 talks. Let's say user 1 says that I can talk only in English, that information will be stored in this guy. And user 2 says that, hey, I can talk only in Spanish, that information will be stored in the signal server 1, right? So now we have the metadata about these two users, right? Based on the metadata, we can establish the connectivity as well. Okay, right? Fine. So signaling server has the metadata about the user 1 and user 2. That's what we talked about so far. Okay. Now let's go further. Okay. So basically the signaling server is the implementation of a framework called ICE. Interactive communication establishment or connectivity establishments, right? It stores all the offer and answer requests in its database. That's what we learned, right? How the signaling server can be implemented? Signaling server can be implemented by using various protocols, right? I mean, various things, right? It could be a WebSocket request, like WebSocket via the WebSockets or HTTP, plain HTTP request as well. You can pass the details about your users into the signaling server. Okay. Okay. Yeah, Ranjit, I think we'll talk about that. We'll talk about recording as well in detail. Okay, fine. Right. Okay. But yeah, before we talking about the design, want to cover on the certain basic aspects of the WebRTC, which we will be using for design. Yeah, Abhinav, yes, it will store the IP address, at least their public, private IP address as well within the signaling server. All metadata about this particular guy will be stored here. Okay, fine. So I think the why we are using the signaling server, basically to establish a connectivity between the peers, right? The metadata is there. Using that metadata, maybe we can establish a connection between A and B, or user 1 and user 2. Okay. Yeah, so SDP, we can use SDP anyway, any protocol. You can use WebSockets or you can use HTTP. It's basically passing the information from client to server, right? So that can be implemented in any way, right? And by the way, there are, if you're using any cloud service providers, right? So there are various publicly available signaling servers as well. Like I know like Pubnum is one of the signaling server, which we can use it as well, right? If you're leveraging any of these cloud providers. Or you can build your own signaling server as well. Basically, one database which stores the user metadata, like a key and a value, a kind of a configuration. Okay, right. Cool. Okay, great. So signaling server is good. It's an important component to understand metadata about the users, right? But we talked about we need a public IP address, right? In order to establish a communication between the two guys, we need to we know the public IP address. If I know the public IP addresses, then I can establish a connection, right? That's what we know, correct? That's what we just talked about, right? The Airtel Jio scenario, right? If I know the public IP addresses, just like what we have seen, sorry, just like what we have seen in this visual diagram. So if I know the public IP addresses, I can establish a connection between user 1 and user 2, right? These are the public IP address of user 1 and this is the public IP address of user 2. So both are almost the same, only the port number is different. Okay, so that's what we talked. Then how to get the public IP address? Okay, that's where you have something called stun servers. Basically, the stun server is used to get the external public network addresses. Okay, understood? So stun is a kind of a server, right? Basically, it is implemented using the WebRTC protocol. So what it does is this guy will send an ICE candidate to the stun server. Basically, background, we are not doing anything. Whenever you are implementing the WebRTC protocol, in the background, okay, it will do certain calculations, meaning it has an algorithm, the protocol has some algorithm to identify the public address for a given user. In this use case, in our use case, for user 1, this is his private address. We have done some translation and identified that the public address is this. This is the public address of this user 1. Okay, so that stun, right, we'll internally call the NAT logic and all. I mean, the WebRTC protocol internally does some calculation and identify the what you call the public address of this user 1, right, and send a packet called ICE packet, right, or ICE candidate. Right. So basically, we have a stun server. It will send the user's ICE candidate. What is this ICE candidate? ICE candidate is nothing but some kind of a message which will have the public address of this user. Okay. So this is been taken care by the protocol only. Right, you need to follow certain steps, right, a certain functionality, a certain configurations, then automatically the protocol will identify or prepare an ICE candidate. That candidate or that message will have public address of this user 1, and this public address will be stored within the stun server. Okay, similarly, same thing will happen at the user 2 as well. Right, so both are Zoom users. Zoom client has been installed. The Zoom client or the Zoom will ensure that it runs certain functionality to identify the ICE candidate. The ICE candidate will have the public address of this user 2 as well. So both has this ICE candidates. Both the stun server has the public address of user 1 and user 2. Now we have identified the public addresses of user 1 and user 2. What we can do, we can just establish a connectivity. We can establish, so using the public IP address, I can connect to this user, right? Using the public IP address, I can connect to this user and talk to this guy directly. That's how I am establishing a peer-to-peer communication. Right, so when I'm establishing a peer-to-peer communication, I want to know the metadata about the user. That metadata about the user, I can get it from the signaling server. Got it? So what is the API we have? We have the first API is, first important API is get user data, get user metadata. Right, so this is one of the API we have within the WebRTC. If you see my first explanation, get user media, sorry, not metadata, the user media, right? So this is the API. Using this API, we are able to identify the metadata about the user, and we are storing that metadata in the signaling server. So this is, we call it as offer process or answer process. Okay, so this is one of the API which we are leveraging from the WebRTC protocol, right? So the next API is peer-to-peer communication, peer connection, right? So what we are doing here, we have identified via the stun servers, I have identified the public IP address, and I'm calling a API called, I'm kind of talking to this other client by peer connection. Okay, so I am via this API, I'm talking to this my peer, my user 2, where I know the ICE URLs are the public URLs of the user 2. Okay, so this is one more API which is available in the WebRTC world. Am I making sense? Clear? So this is one more API which is available in the WebRTC. First API is get the metadata about the user. Second API is establish a peer connection using the ICE URLs, which is nothing but the public URLs. So since now the connection has been established, now the third API is send the data channel, right? So connection has been established. You just need to send the data, send the bytes, right? So for which you have another API called data channel. Data channel is, since the connection has been established, you will call the data channel API with connection as a parameter. Connection is been established by API 2. The output of the API 2 is nothing but connection. So that you got the connection now, the API 2, you got the connection. Now using that connection as a parameter via the data channel API, you are passing the message to the other guy, right? So this is how we establish the peer-to-peer connection between the two users, so that you can send super fast data, or you can achieve the performance aspects, which has been one of our ask. Okay, am I making sense? I'll just repeat one more time. We have an API called get user media within the WebRTC. Using this API, you are able to get the user metadata, like what is his IP address, what is the bandwidth of that user, what codec he can support, what audio codec he can support, all those details, you will get it, and you will store all this information in the Signal server. Okay. So now you have the metadata about the user, right? Now you will be trying to establish a connection between the user 1 and user 2, right? For which you will be calling the stun server to identify the public address of the user 2. So the user 1 is talking to the stun server and identifying the public address of user 2. So he got the public IP address, which is nothing but the ICE URLs, right? Using that public IP addresses, he is making a connection. The connection has been established. Since the connection has been established, what you're doing, you are sending a data connection along with the bytes of memory or whatever it is, stream or a bytes, you will be sending it over the data channel. Okay, so this is how the high level flow of this is the high level concept about the WebRTC. I'll stop here to see if there are any questions. Okay. Okay. I think I'm not sure where I left. Okay, Pooja, I think I covered it. Abhinav, I think I covered it. Does SDP work? Yeah, I think I covered it. Okay, so but the IP address can change. So how do we handle? Abhinav, to your question, right? That's where NAT will take care. Correct? Why are we using this? See, if you go here, right? So IP addresses will change. Today the user has this IP address, right? But tomorrow the user's IP address will change to so and so, right? So the NAT translation will take care. Hey, this public IP address, port number 1, is associated to this user. That mapping will be taken care by this NAT provider, or the NAT will take care of that, right? So since the IP addresses are dynamic in nature, right, but each and every IP address is connected to one of the port or one of the port within the public router, right? What happens is, this is how it maintains. This public IP address is being mapped to this particular user. 0.2, something like that, right? That is how the mapping will happen. So tomorrow, this 2 has been changed to 3. It will be updated. So the NAT translation will take care of that. NAT translation will ensure for each and every private IP, there is a corresponding public IP. Public IP will be almost the same for all, but the port numbers will be different. If I recollect, I think for any server, there will be 64 ports. A physical server, there will be 64 ports. Fine. Okay, I think Abhinav, I got your, okay. Next question is from Avinash. The user one is initially connected to the signaling server using, so as I mentioned, right? So Avinash, to your question, the user one can connect to the signaling server via any protocol, typical normal HTTP protocol as well, or WebSockets. As a general practice, people generally use WebSockets because it's a two-way communication, right? Because we need some bi-directional communication as well, correct? Because you send an offer message saying that, hey, user, I'm sending an offer message to user 2, and user 2 might send a answer message saying that, hey, yes, I'm acknowledging this guy, please go ahead, right? The bidirectional communication is required, hence generally they use WebSockets to establish a connectivity between signaling server. Okay, did I answer? Got it. Okay, cool. Okay, any other questions, team? Hope I'm making sense. Okay, fine. Okay, fine. All good. All great. I think someone has asked a question, right? Hey, accessing public address is not a security concern. Of course, it's a security concern, right? Not for general consumer use cases like talking via Zoom and all. But there could be some cases, like let's say this user 2 is in some army network, or he is working for an Indian army, and he is working in Indian army headquarters or somewhere. There are a lot of firewalls. So their network has a lot of other firewalls and all, right? So their network may not allow you to share the public address, even though you can access, but they have certain rules not to share the public address to the user one, right? Because of some reason, we are not able to identify the public address. Okay, how to deal that, right? For some unknown reason, we are not able to get the public address. How to deal with that is, there is something called turn server, right? Basically, hey, we are not able to connect to this guy, please help us, right? Something like this, right? Okay, you can talk to your neighbor directly. Okay, that's a peer-to-peer communication. But for some reason, you're not able to talk to your neighbor. Maybe there is some disturbance, or there is a wall in between, or something happened. You're not able to pass the information to your neighbor. What you will do? Maybe you will use some kind of a relay mechanism. You might send your servant, or send your someone at your home to pass a message to your neighbor. Basically, relay my message to the neighbor, right? For which, in this worst case scenario, if you're not able to establish a peer-to-peer communication, that could happen because of various reasons. If peer-to-peer communication is not been established for some reason, then we use a relay server. Relay the traffic from user 1 to user 2. This is typically not a peer-to-peer kind of a communication, but a worst case mechanism. If peer-to-peer communication is not working, still my video should work, my video translation should work. In those scenarios, we introduce something called turn server, right? This is the server which will act as a proxy for us, which will pass the information from user 1 to user 2. Okay, that's the turn server, right? So not all cases you may not be using the turn server. Only the cases where we are not able to identify or not able to establish a peer connection, then we'll go via this turn server. Okay, makes sense, right? So what is the full form of the turn server and turn server? So the turn server stands for, maybe stun stands for what is that? Session traversal utility for NAT. Okay, and turn stands for traversal using relay for NAT. Right. So traversal using the relay for NAT. Okay, so these are typically the full form of these servers, right? Stun and NAT stands for. Okay, fine. Makes sense, guys? Oh, hope you got some high-level understanding about the WebRTC protocol. So now we will go to our problem statement. Before we go, is there any other questions? Makes sense so far? Okay, great, good. Okay, there was one question from Vibo. What happens if any user get offline and back online after sometimes new connection and used? Yes, so if the connection, the connection, right, this we will retry. There will be retry mechanism if a connection got lost, right? If the user 2 is out of network, right? So this connection guy, right, while sending the data channel, it will do, if the connection is null, it will do the retry mechanism. All those concepts will be implemented. It will do retry by calling this connection API again, so that it will try to establish a connection. Okay, fine. Cool. Okay, fine. I think we kind of talked a lot about the WebRTC protocol. I assume we got a high-level understanding, but this is how the WebRTC works. So basically, generally speaking, the WebRTC connection goes like this, right? From your device, you talk to the stun server to understand the public IP address of your destination, right? Now, using the destination public IP address, you establish a peer-to-peer communication and transfer the message to the recipient device. So this is how the WebRTC works, right? So this is a high-level overview on how WebRTC has been implemented, right? And the architecture of the WebRTC has been mentioned over here, right? So I would say, like, there are a lot of good materials available on the public portal or public internet. You can go over that to understand more about WebRTC. But at a high level, so these are the prime APIs which you will be using to establish a connectivity between the users. Okay, fine. So there are a lot of cloud provider are like CPaaS, right? Communication protocol as a service, right? So all the stun servers, turn servers, signaling servers, all those things are being provided as a service to you guys, right? So if you are using any cloud like AWS or Microsoft Azure or Oracle AC or Oracle OCI, like Oracle Cloud Infrastructure or any other cloud provider, so they do have exposed their APIs, which is communication protocol as a service, like the signaling services or the stun servers, turn servers are being provided as a services as well, right? So this way you can establish a real-time peer-to-peer communication if you are using any cloud provider, right? If you're not using cloud provider, you can also deploy your own signaling server, deploy your own turn server and stun server and implement that real-time communication. Okay, so that makes sense. Okay, I'll take a break of 1 minute to see if it is making sense, right? If yes, we will go over to the design aspect. So we spent quite amount of time to explain the WebRTC, right? So if you understand the WebRTC, I think the design should be easy and simple. Maybe we can complete our design in next another 15 to 20 minutes. Can't we use RTSP? Harsh, I'm not sure what RTSP mean. Maybe can you elaborate a bit on that? Harsh, if you are speaking, you are on mute. You need to unmute yourself. Real-time streaming protocol. Yes, but streaming is something like it is being used when you are kind of watching a video, watching a movie, something like that, right? So someone is pushing a message, right? But here it is two-way peer-to-peer communication, correct? So that's the only, yeah. So as Anil mentioned, right? Streaming is one way, whereas chatting is two-way. It's a bidirectional, right? So that's the reason we go with this WebRTC kind of a protocol for real-time peer-to-peer communication. Okay. So Ranjit, I think your question was how the public IP address or how are we getting the IP addresses of a customer, correct, or an user, right? Let me simply mention that, right? Okay, so you are user 1 and this is user 2. Okay, user 2 both have installed Zoom application, right? This guy is installed Zoom application, this is also installed Zoom application. So both are using the WebRTC protocol because Zoom, right? Both are Zoom application. The application has capabilities of WebRTC. Okay. So by leveraging the WebRTC, what we are doing is we are trying to do the NAT. I mean, this RTC protocol, WebRTC, has internally called the NAT APIs and trying to identify, give the public IP. Okay, so the application, the Zoom application, internally running some background service, right, which internally calls the WebRTC specific functionality or the WebRTC specific framework to identify the public IP address. So that public IP address is stored on the stun server. Okay, how it is being stored? So this user 1, the Zoom application, this guy is sending that information, whatever the public IP address which has been identified, is being sent to this stun server, right? So this mechanism we call it as ICE candidate. ICE candidate. Right? So basically what the ICE candidate is doing, it is sharing the IP address of this user 1. Okay. Since Zoom application has been installed or the Zoom browser is running, right? Internally, it is invoking the WebRTC protocol, identifying the public IP address, and once it has been identified, it is sending it to the stun server. The same mechanism will be implemented or will be followed on this guy as well. Okay, some background process is trying to identify the public IP address of this user 2, right? And it will send the public IP address to the stun server. Okay, right? Now the stun server has the user 1 public IP address and the user 2 public IP address. So since we know the public IP address, we can establish a connection between user 1 and user 2. Does it make sense?
Yes, it makes sense. But what if the user 2 is offline? Then stun server doesn't have the public IP of user 2.
Yes. Yeah, that's what, right? If I need to call you, right, one-on-one call, right? I'm calling, let's say you, right? Ranjit, let's say I'm calling you, right? But you are not available. You are not online. You will not receive the call at all.
Okay.
Right? Because I don't know. You are not connected to the system at all. Correct? I may not be able to make a call, right? But yeah, so there are certain options. Example like WhatsApp may kind of send a message or might give a ring call so that you can accept if even though you are not online, right? Some other mechanisms will be there. But in short, if you are not online, nothing will work.
Okay, so if my app is in background, then also I need to send my public IP to stun server so that
right, then call will have established. As long as your user 2 is connected to internet, right? Some background process is running, and that background process is sharing your public IP address to this guy.
Okay, thank you.
Okay. So I think there was one question. Port numbers are also sent to the stun server. Let's answer your question, Karthik, right? Let's say this both this user 1 and user 2, both are Airtel users, right? Both are working from a same town. Okay, right? So what happens is this public IP address of the user 1 could be something like this: 44.55.66.77 port 100. Okay, so this guy is also an Airtel and one working from the same same city, right? He is also connected to the same server, same router, right? As this guy, user 1. So his public IP address could be something like this: 45.66.67.101. Okay, so basically just to represent what happens is both are connected to the same physical router. On the physical router, there are multiple multiple ports. This is, let's say, port number 100, right? And there is one more port, let's say, one more port called, let's say, port number 101, right? So both are, right? So this guy, this on this physical, okay? So which means that this guy, this user 1 device computer is connected to this particular port on the Airtel router. Okay, this guy is connected to this particular IP address or a particular router at this port number. If you see here, both are on the same IP address. The IP address of this guy is like 44, 55, 66, 77, right? But the port numbers are different. Okay, so we definitely need a port numbers, right? In order to have a public IP address. I think I hope I answered your query. Okay, great, cool. Yeah, I think enough we spent on Webrtc. I assume you guys got the concept, but I'll share this presentation if things are not very clear. In short, Webrtc is a protocol for real-time communication. Okay, we use the Webrtc protocol to build our video conferencing system. Okay, fine. So let's talk about design. Hey, how are we trying to design? Right? We talked a lot about Webrtc. So the design approach, we decided that scalabilities are important non-functional requirement. Elasticity is one of our non-functional requirement. So let's decided that let's go with the microservice architecture so that we can support scalability better. So microservices architecture comes up with a lot of rules like adhere to single responsibility principle, build a loosely coupled system and all that, right? In order to adopt that, we have leveraged domain-driven methodology to break the entire component into small chunks, small capabilities, small domains, right? So these are the domains which we have identified. Of course, I have done it prior to this session, but you need to go to your dashboard, your drawing table and identify what are the domains. So based on the requirement, we know that, hey, there will be n number of users. Each and every user might need to register to our application, or we need to have certain information about the user. So I have created a domain called user management. Hey, we have a group calls, right? So there should be some kind of a mechanism to manage the group. So I have identified a group management domain, which takes care of managing all the groups. Okay. And hey, we need to store the messages, right? So there will be a lot of messages will be sent to and fro. All those messages need to be stored. So I have created one more domain or one more component, which will take care of message management. Okay. And we have a requirement to record the videos, right? So I have created one more component whose responsibility was only to record the video or audio, which is under progress or something like that. We need to have a notification system, right? Hey, some notification system to notify if the user has successfully registered, or if there is a group message or a meeting invite that need to be sent, right? All those things will be there. So we have created one more module called notification management. Okay. Hey, in the chat, I can send some memes, or I can send some pictures and all that, right? So I need to store these pictures somewhere. I need to have some asset management system. Okay, so we talked about WebSockets, right? As one of our examples, we need to have certain WebSocket handlers, WebSocket management, group management handlers, and all those things, right? So these are the various components which have identified. I'll talk in detail as well, right? But these are the components which we have identified. So using this, I want to kind of design a system. Okay, let's go back to our things, right? Okay, so first is user management, right? So I have a lot of users, 1, 2, and 3. These want to kind of register into a system. Okay, so what I have a system, or I have something called user management service. It's an API which is running on one of our instance. Okay, let's say this user 1 is registering. What happens? It via the load balancer, because to manage the more number of users, to provide the scalability, we do have load balancer because we have n number of servers, right? So the user management call will come to this guy. Okay, user management write API. What it will do, it will recreate an entry in the database. Hey, user ABC has registered, his email address is so and so, and his location is so and so. All those details will be stored in this database. This is a microservice, a service which takes care of a particular functionality, which is user management. Okay, right? What I observed is, maybe on a given day there will be 100 users who will be registering, but there are thousands of users who are trying to access or who are trying to log in. Okay, so there is more read intensive application, lot of read calls than write calls. Okay, to leverage certain principles like CQRS by microservices pattern, command query responsibility segregation pattern, segregate or separate command which is write and read separately so that you can scale, right? Since it is a read, what I'm saying is we'll have one more read call which will do only read operations, no write, only read only. Okay, it will read details about the user. Since it is more read, okay, what we identified is, hey, a lot of people are coming to our system for read. In order to support that, we are increasing our servers. We are adding more read instances so that we will support more read functionality, right? So this is the advantage of microservices from scalability perspective, and this framework is called CQRS command. This pattern is called CQRS, command query responsibility segregation. Okay, so this is how I built a user management application. Okay, so, and if you see here, this guy user read is talking to one database, right, and the user write is talking to one database. To establish this, what you call loose coupling, no tight coupling should be there, right? That's the reason we have a separate database, but asynchronously the data has been replicated between these two databases to ensure there is no challenges, no mismatch of data. Okay, this is how I implemented the user management. Okay, so there are group management or meeting management, right? Hey, I am creating a new meeting request, right? I have invited so and so people, right? So that as soon as a meeting has been created, let's say today Jitender or Zara from LearnBay has created some meeting request, right? So what they do, whenever they create a meeting, it will go to this group management or a meeting management service. Okay, what it will do, it will say that, hey, meeting number 1 scheduled from 10 to 12, right, on this particular day, which is 8th of August, right? Sorry, 6th of August, right? This has been invited to so and so people, right? So all those checks will be stored in this group management database. Okay, so straightforward. These are relational database. I want to maintain a relationship because if you see here, this meeting is scheduled only for certain people, right? I want to know the relationship and all that, right? For that purpose, for the simplicity purpose, I'm going with that relational database. As well as the user, we need to know, maintain some kind of a relationship. This user, this address, this email address, all those things, right? So hence, simple, straightforward microservices I have built, and these are working independently, taking care of group management and user management. Okay, and these are relational databases. So far good. Any questions? Okay. If no questions, yeah, we'll move ahead, right? Okay. And the next is message communication, right? I think we kind of talked about this, but I'll repeat it again, right? So now we have identified these components. If you go to our presentation, we have identified certain components called WebSocket handler, WebSocket management, and group management handlers as well. Okay, fine. Okay, so now the use case here is message communication, one-to-one message chat. Okay, within this requirement, we need to support one-to-one chat as well. Let's say the user one want to send a message to user two. We kind of talked about it, but I'll go over this message again. So here, what we have done is we are using the WebSockets for message communication. We can use Webrtc as well, but I have used WebSockets here. Okay, so because I don't have super fast requirement here, right, to save the cost, I have gone with the plain WebSocket mechanism. Okay, user one is want to send a message to user two, right? So user one sent a message via the WebSocket handler. He has connected to this guy, WebSocket handler, and he has sent a message. Hey, send hi to user two. Okay, what it does, flow number two, what it does, it will store that message into the database. Okay, so the message, let's say that message is hi, right? So what we are doing is we are calling another component called messaging service, which what is its responsibility? Just take the message, dump into the database. That's it, right? So I got a message, right? And I'm storing that message into the database. Here I'm using a different database, not a relational database. Considering the performance, the messages will be huge, right? And it is not structured. I cannot say a proper structure for any message. The message could be audio, video, or a plain text as well. There is no proper format. For that purpose, since it is not, I don't need to maintain a relationship, I went with a NoSQL kind of a database, which is Cassandra, suits well in this use case. Since I have gone with Cassandra as a database. Okay, good. Step number one, message has been sent. Use what it does, the socket handler storing that message by calling the messaging service. The message has been stored in the database, right? Now that message need to be sent to user number two. What it does now, step number three will invoke. What is the step number 3? It will query against the WebSocket management registry or a database where it will know user one, where the user one is connected, where the user two is connected, and all that. Okay, so it will query against this WebSocket management to check where the user two is. Okay, now we identified that the user two has been connected to socket number 2, right? So now that information is been sent to this guy. Hey, WebSocket handler 1, hey, you can send message to user 2 via the socket handler 2. Right, so step number 4 will be invoked, where via the WebSocket we are able to establish a bidirectional communication and send a message to the user 2. So this is how we have enabled the chat mechanism or message communication. Okay, let's say the user 1 is sending a picture like happy birthday picture to the user 2. Same protocol here, same flow here, right? But here we identified that message contains audio or a video or an image, right? Some kind of an asset, right? What we are doing is, hey, I have an asset, right? I can't save the asset or the image directly in my database. I want to, considering the performance and all that, okay, maybe I'll save the asset in my asset management system or asset management database, right? Via the asset management service. So the message will be stored here, but the message will have a reference to the asset ID. The asset ID is being saved in the asset DB, right? In this case, I'm using AWS S3, all right, which is like storing the blob or a glob kind of a thing. Okay, so this is how I have implemented the message communication system. So for good. Okay, cool. Let's talk about the group call. I mean, the video call, sorry, not group call, the video call. Hey, this is where we will be leveraging our Webrtc. Okay, so the use case here is user 1 want to have a video call with user 2. Okay, so both are connected. Let's assume both are connected, both are online. Okay, right? Both are connected, both has some, okay, I'll stop here. There looks like a question. Okay. Yeah, Pooja, I think this session is not to talk about when to use SQL or when to use NoSQL, right? Maybe we can have a detailed session to talk about that, right? But when to use, maybe make to answer your question in a one-liner, right? If the requirement is scalability, right? Then I would prefer to go with NoSQL database, right? If the requirement is to maintain some kind of a relationship, then I'll go with the relational database or a SQL database, right? So considering the scalability, people prefer to go with NoSQL databases. Again, in NoSQL databases, you have various types of databases like key-value pair, like Redis, document DB, like MongoDB, wide column DB, like Cassandra, right? And Hadoop and all that, right? Again, that's a different topic. I don't want to confuse people here. If required, we can have a separate session to talk about SQL versus NoSQL DBs. Okay, but in short, go with NoSQL if you have a scalability requirement. Okay, great. Okay, cool. Yeah, so now let's talk about the video call. Correct. So the use case here is user one want to talk to, or user one want to have a video call with user two, right? That is the use case, right? Cool. So how to do that, right? We learned the real-time communication will help via, we can establish a real-time communication via the, what do you call, WebRTC. So we will be leveraging the WebRTC now. Okay. So what happens? Right. So all these guys are connected to some kind of a application or some kind of a socket, WebSocket handlers, right? Why we are connected? Because I want to know the details about this user, right? I want to have established some connection about with these users, right? The user one is connected, user two is connected, right? As they are connected, right? Maybe I represented just for user three, right? So as the user three is connected, right, where the Zoom application is running, as mentioned in this one of the thing, right? Zoom application will send all the metadata to the signaling server. That's what you will see here. So the user one is sending all the metadata to the signaling server. Okay. What is the metadata? The metadata will have what is my IP address, what is my bandwidth, what is my what video I can accept. I mean, what if the video is in so and so pixel, I can accept, right? Because I'm running on low bandwidth, please translate the video, if a high definition video, to the low definition video and give it to me, right? Those kind of things will be mentioned in this signaling database, right? So the user one, typically all users, we are kind of sending the metadata to the signaling services via what? Via the offer call or answer call, which we kind of talked a couple of minutes back, right? What is this offer call and answer call? Which is nothing but SDP protocol or SDP messages, not protocol, SDP messages, which is session description messages or protocol, right? This is, I think, session description messages or protocol, right? So this is the messages which we are sending it. What message this will have? What is my IP address? What is my bandwidth? Right? What is my what is the codec I can support? Right? What is the encryption mechanism I use? Right? All those details will be saved in this message. Okay. Right? So let's say the user three want to talk to user one, right? So via the offer, we are sending a message to the signal saying that, hey, I want to talk to user one. User one signaling server will talk to user one saying that, hey, you got a request. Do you want to accept that? They'll say that, yes, I'm answering it. I'm accepting it. So this guy will send an answer message to the signaling server, right? With all the metadata. Okay. Now I have in the signaling server, I have the metadata as well, right? Okay, I think I might not have mentioned this guy. And 1 second, sorry guys. Okay, so yeah, so this is what the signaling service has, all the metadata, right? As mentioned, the user 3 have installed the Zoom application. So it has the WebRTC kind of a functionality, right? So WebRTC protocol is sending all the public IP addresses to the STUN server. So the STUN server has this public IP addresses as well. Each and every component has its own database or a data store. I did not represent, but yeah, let's assume there is some kind of a DB here as well, right? I have not determined what database it will be, but typically it might be some kind of a NoSQL kind of a database, maybe some kind of a MongoDB or Redis or something like that. Okay, got it. This is how we have built these components. Okay, so now user 3 want to talk to user 1. Okay, what it will do, we will query against the STUN server to identify the public IP address. Let's say we got a public IP address. Okay, so using that public IP address, we are able to talk to the user 1. Okay, what happens basically, we are establishing a connection, a peer-to-peer connection between user 1 and user 3, right? Using the public IP addresses which we identified via the STUN servers. Okay, so now connection has been established, right? So via the data channel, we can send the messages, or we can send the video from user 3 to user 1. Okay, what if I need to record, right? So when this message is being transmitted, we'll be having some kind of a filter or some kind of a check, something like this. If record is on, send that data similar to user 1, send that data to this record management. Okay, so what the record management will do, it will stream, or it will get all the video or audio that is being under discussion or under passage to this record management, and the record management will save it in its database. Okay, this is at a high level on one-to-one video call. I'll stop here to see if there are any questions. Does it make sense? I'm happy to repeat again if you have any questions or if I'm going fast, but the intent was to ensure you're able to understand the design. Okay.
So is there a turn server in user 1 side as well?
Yeah, so yes, basically I was not able to represent everything in a one thing, right? But if you see here, so the user 1 also will talk to this STUN server, right? All these guys are connected via the WebSockets, right? Okay, basically via these WebSockets, they're able to, all these guys are sending their public information or public IP addresses to this STUN server. Similar to user 1, everyone will be kind of emitting their metadata about them to the STUN server. Am I making sense? I think there was some question. Okay, Avinash, you missed on the recording part. Okay, cool.
Yeah, I get that there is a recording service that is listening to the video or like audio, and it is getting that from somewhere, but where, like, it is listening to the WebSockets from where that audio is passed.
Sure. Yeah. So here, right. So we establish user 1 to user 3. We have established a peer-to-peer communication. Correct. Right. Via the public IP address. Correct. Yes. So far you're good, right? So now we are able to communicate. Cool. Right. So now somewhere we know there is a metadata about that meeting or about that thing about in the client. Somewhere we know that basically how we can say is, I did not represent that messaging pattern here, but one second, I'll add one part. You have messaging service as well, right? Messaging service, right? Okay. So what happens? So this when even though you are chatting, even though you are having a video call, even till you have an option for chat, right? Just like how we are having it, you can still send the messages. Correct? Okay. So the messaging service is there, and also there will be some kind of a metadata about that event or that call. Something is happening, right? So Sharath is calling Avinash, right? So it's an event, correct? I need to store that event or something about that part for tracking purpose or whatever it is, right? So what I'll have is one more thing. 1 second. This is, let's say, event service as well. I'll explain. Give me a second. Fine. So let's say here user 3 is Avinash and user 1 is Sharath. Avinash is calling Sharath. Okay. So Avinash kind of initiated an offer call to Sharath. 1 second, guys. 1 second. I'll complete this and I'll come back. Okay, good. Okay, fine. So let's take a use case. Avinash is requesting for a video call with Sharath. Both Sharath and Avinash are online, right? Here the user 3 is nothing but Avinash and user 1 is nothing but Seth. Okay. So in the background, Sharath's application or Sharath's computer is able to send the public IP address to Sun server. Similarly, Avinash application at the computer is able to send the public IP address to the Sun server. All good, right? Now we are able to identify the Avinash is able to identify the public IP address and he was able to establish a connection between the Sharath, right? Before that, what happened? Avinash has initiated an offer call in order to identify the public address. Has initiated an offer call. Hey, I want to talk to Sharath. So it will went to the signaling service will have metadata and all that, right? So we are saving certain details in that event database. What is the event database? Avinash called or Avinash requested an offer at 10 o'clock. Okay. This is what we are storing in this event database. Okay. Sharath has replied, as is for Sharath. Sharath has acknowledged the offer from Avinash with an answer call or with an answer message at 10:01. Okay, right? That's the event thing. We'll be storing it, right? Along with that, both Avinash and Sharath has agreed to record this message, record these conversations. Or before that, Avinash got Sharath's public IP address. So this event we are recording it as well. Okay, and Avinash requested, or Avinash and Sharath requested to record it as well. These are the list of events which we are recording via the event service. Okay, so there is some kind of a flag or some kind of an information to our system saying that we need to record this, right? So once the communication has been initiated, right, via this flag, we have identified that we need to record. Okay, so what happens is this guy, Avinash, the client application or the Sharath's client application, somehow it's invoking the record management functionality. Got it? What this record management functionality will do? It will try to read the data and kind of store it in our system, right? So this is the high level thing, right? What happens if the record flag is enabled? Maybe it will put it into some kind of a queue or some kind of a Kafka, right? Some kind of a queue, right? Whatever the stream or whatever the bytes, which is the record, it will put into some channel, some kind of a queue or some kind of a channel, right? And this record service is polling on this channel and it is storing it in its database. Okay, that's how we will be implementing the record functionality. Did I answer your question, Avinash?
So in that case, the channel, the communication, the bytes has to go through that channel.
Correct. Yeah, this can be implemented in multiple ways, right? Yes, maybe the record management, what it will do, maybe it will poll on this particular guy, this channel. As soon as the message is there, it will dump into this record management. This is nothing but a listener. That is one way to implement it, right? To simplicity, what I have done is maybe this guy will call record management via the sync service, via the load balancer, and it will put it here. Basically, the streaming functionality, we can use it as well, right? That's one option. Multiple ways this can be implemented, right? You can implement either way. Making sense? Did I answer your question?
One question is coming to my mind is like there is the WebRTC protocol, and then we have established Kafka queue, let's say. Then the audio and video bytes, they are going through WebRTC protocol, and then they are going through the Kafka queue also.
Yeah, Kafka queue just to record. Correct. So WebRTC is for the real-time communication.
Right.
Correct. WebRTC via the real-time communication. Avinash is talking to Sharath, right? But there is a requirement to record. So what we are doing is parallelly, we are putting that message, whatever the message which is being under discussion, that has been kept into the Kafka queue so that someone in the background asynchronously can read all this message and save it in our database for future. Because record is enabled, in future we can use this. This is an asynchronous call. Am I making sense?
Yes, makes sense. Yeah, thank you.
Right.
Okay, so in that case, there might be a scenario where the communication might happen and the Kafka doesn't get the required packets.
Yeah.
The exact recording might be different from what they talked in real time between peer-to-peer connection.
Correct. Correct. Right. There could be some cases like that, right? For some reason, if you're not able to put the message into the Kafka, of course, you will lose your recording, right? So how to handle that? You need to think about various options, right? Maybe somewhere in the client, you need to buffer it or you need to save it so that whenever the Kafka is up and running, then you need to push it, right? There are various mechanisms, various patterns you need to think about if the data loss is an important aspect, right? Every aspect of the record need to be there, right? Then you need to think about that. Maybe you need to stream within your local application, and asynchronously after 30 minutes or after 1 hour or after the end of the meeting, maybe you can push that data into the Kafka. Various mechanisms can implement.
Okay, so one question. So whenever recording is happening, then also the communication is happening peer-to-peer, not through any server. Yeah,
this is not via server, right? In this use case which we talked about. Okay. Since we have established a peer-to-peer communication, we are via public IP address, we are able to communicate directly. Okay.
What happens really in WhatsApp calls or mainly Zoom calls or WebEx calls where we can record? So does that also use public IP, or is their mechanism little different from what we are seeing here?
So generally, right? So again, the architectural proposal which we talked about is one way to implement it. This is one way where we can implement it, correct? So how Zoom implements? Sometimes Zoom might use some third-party example, which I mentioned in the what I call in this diagram, right? We can use CPaaS, communication, right? I mean, real-time communication protocol as a service, right? Communication protocol as a service, right? So the Zoom or WhatsApp or any other guy might be leveraging the existing communication platform as a service functionality which has been provided by some services. Maybe Zoom is using some service provided by some vendor, which is very stable, robust, and all. But in the background, all this communication protocol as a service will leverage the same concepts which we talked about. In the background, it might use the WebRTC itself, right? It has the signaling service, it has a stun server, it has a turn server, and all that. Okay, so this is one way they use. Or they might leverage any other third party like voice. Example, in telecom world, there are various products which will allow, if you understand the telecom, right? Like I'm calling you, I'm calling your number, and that is happening real time, right? On the phone. Okay, they are using some other products there. Maybe they can use those third-party products as well. Okay, to establish this communication to establish this communication. Okay, so there are multiple ways which we implement it. They all depends on cost. Since we want to build something from scratch, we thought of leveraging the Webrtc. Right, nowadays the Webrtc is supported in all the web applications, right? Which means that if you're attending any Zoom call or any Meet, Google Meet calls from the browser, most likely 99% of chances they are using the Webrtc, because the Webrtc support is there in all the latest browsers like Google Chrome, Microsoft Edge, and any others. Did I answer your question?
Yes. So in case of CPaaS, there is a chance that the communication is not happening peer-to-peer and via the CPaaS service provider.
Right. Yeah. So now your question, right? Hey, for some reason, because of security reason, I'm not able to get the public address. I'm not able to get establish a peer-to-peer communication. What is my option? Okay. That's where we talked about turn servers. What is the turn? This is acting as a proxy for us, right? So whatever the video you're doing, it will go to the turn servers. Turn servers internally communicate to the user, right? It is relaying the information to the user. This is not very peer-to-peer because you have an intermediary proxy in between, but this is the worst case scenario. If peer-to-peer communication is not happening, then we will leverage the turn servers. So turn servers are implemented, is again part of the Webrtc. It is implemented or streamlined better to support the real-time communication a little faster. Again, still there will be latency will be there because you're using an intermediary proxy in between, but it might help a little better. Okay, so that's also one of the component or one of the server within the Webrtc if we are not able to establish a peer-to-peer communication using the public IP addresses. Making sense? Okay, cool. Any other questions, team? Okay, fine. I think we almost kind of talked about the one-to-one chat, one-to-one video call, how it will work, right? On the same lines, it will work for the group chat or group videos. Okay, how it will work. Let's say, Avinash, I know we are top of the hour. Is that okay if I continue for another 5 more minutes? 5 to 10 minutes? Is that okay, guys? Yeah, cool. Okay, fine. So yeah, so let's say the group functionality, right? You want to do a group call, right? Let's say Avinash. Okay. Yeah, so Avinash want to kind of talk to user 2 and Sharath in this use case, or we want to have a group call. Okay, so what we will be doing it, right? Avinash created a meeting request saying that, hey, let's connect for some triage. There was some bug production issue. Let's triage, let's have a group call. Okay, so Avinash scheduled a meeting request. What happens? Let's say this is the Avinash. Okay, via this group management service, he created a group meeting request. That meeting request is being stored in the database. In the meeting request, he mentioned that valid users are Sharath and user 2. Okay, via the notification service, we kind of talked about in our design. We have a notification service. Via the notification service, an email has been sent to Sharath and user 2 to join a call. Okay, this notification service might be sending some email or SMS or whatever it is, right? So this notification sent an email to Sharath and user 1 for a meeting. Good. Okay, fine. The group management, we got what information we have. we have meeting ID. Okay, we have who are the participants? User 2 and Sharath are the participants. Okay, and Avinash are the participants for this meeting request. Fine. So this is the information we have, and of course we have the timing as well. It's from 10 to 2 or whatever it is. Fine. All these details are there in the database. Okay, cool. Group management has this. Okay. Now let's assume, right? Let's assume we want to initiate a call. Right? Everyone need to have an initiating call. So I need to establish a peer-to-peer communication. Okay. So what Avinash will be doing, Avinash has initiated a call. Okay. So he is sending an offer message to user 1 and offer message to Sharath saying that, hey, I want to call, right? This is my metadata. This is the details about me. My IP address is so-and-so, my bandwidth is so-and-so and all that. Okay. So these guys have accepted. Hey, Avinash, thanks for calling. This is my answer. This is my IP address. This is my bandwidth. This is my so-and-so details. Same thing with the user. All those metadata has been saved in the signaling server. Okay, fine, right? So how that request, how the offer request went to user 2 and user and Sharath only, because we know, right? For that group, these are the valid people who are allowed to join, right? So how we are able to find? We are able to query against this meeting service, our group management service, and identify who are the valid users, and we are able to identify all the details. Okay, so now all the details are there about the metadata. So we are trying to establish a peer-to-peer communication by getting the public IP addresses of these users by querying against the stun servers. So everyone has the public connection. So we have established a connection and the group call is happening it. Okay, so just like how the one-to-one connections are working on the same lines, the same workflow will be repeated for group as well, or group calls as well. Only difference is we will be querying against the group management service to identify the details about a group or to identify the details about the meeting. That's the only additional check we will be doing it. Making sense? Okay. Yeah, I think maybe I'll spend some 5 more minutes for any questions, but pretty much this is what I want to kind of talk in today's session. Basically, what we have done in today's session is we have identified the functional requirements, right? We have identified the functional requirements, right? And we have identified the non-functional requirements. So based on the functional and non-functional requirements, we have identified the architectural style, which is microservices in our case. And we have also identified certain decisions, architectural decisions and certain principles, right? And as a part of the architectural decision and the principle, we have identified that let's leverage WebRTC for real-time communication. So this is a decision which we have made after learning the WebRTC. Okay, so this is what we have done. Functional requirements, non-functional requirements, architectural pattern or architectural style. We made an architectural decisions and architectural principles, and then we have built a system, right? In the meantime, we have identified or we have learned about the web protocols like WebRTC2. Yeah, you're right, Ranjit. Yes, screen share and video call is on the same architecture. It's all on the byte transfers. Right. Great point. Sorry, I did not touch that part, but that's the valid assumption. Cool. Yeah, I think that's what I have for today, guys. I'll try to, I think I have done some minor changes or minor updates here. I'll try to correct it, streamline these presentations and share across. Any other questions? Okay, so Pooja, how the notifications will work, right? So the notification is like, okay, meeting request is being sent, correct? So let's take this as use case as well. Okay. Right. Okay. So you identified, let's say you have created a meeting request. Okay. Let's say a meeting need to be sent between Pooja, Sharath, and Avinash. Let's say Avinash has created a meeting request. Okay, it will come here. We'll store an entry in the database. Okay, saying that, hey, it is Pooja. Okay, this meeting request ID number 1, who are eligible: Pooja, Sharath, and Avinash. Right. So for Pooja, we know, right? Pooja will query against the user database and see what is his Pooja's communication option. Let's say Pooja, using the Pooja's credentials or Pooja's ID, we have identified that the address is pooja@gmail.com. Okay, this is what we have identified. Understood, right? So what I'm trying to say is, from the group management service, right, we might query against the user management service to identify the details about Pooja. Okay, so we identified that Pooja has opted her communication address as Gmail, pooja@gmail.com. Similarly, for Sharath, for this identifier, I'll go to the user management database and identify what is the communication protocol. So Sharath has determined that I want an SMS. I'm not ready for an email. I want an SMS. He has shared some what you call some mobile number, SMS. Okay, so we got these details for querying against this user management portal. Okay, now we know how to communicate. So what the group management will do, it will put a message into the Kafka. Hey, send messages to this guy, which is Sharath, on so-and-so number, right? This is the message we'll be putting into the Kafka, okay, or some kind of a queue, right? And send a message to Pooja, right, about this meeting request at so-and-so email address, right? So this is the message we put in some kind of a queue, right? Let's say this is the Kafka, right? The group management, after creating a group, has put a message into this guy. Okay, after that, so someone is kind of polling on this particular channel, and this guy will read all the messages, and via the notification services, right? What we are doing, if the channel is SMS, send SMS. If channel is SMS, send an SMS. If channel is, let's say, email, send an email. Basically, we are creating an email client or email, are leveraging some email provider and sending in emails to the customer. Okay, did I answer your query, Pooja? Okay, so this is how the notification service can be implemented. Okay, thanks, guys. Okay.